So, what happens when our ability to actually see the weather completely fails? Today, we're going to break down a report that uncovers a pretty shocking reason behind a recent climate catastrophe. And here's a spoiler: it's not just about bad weather, it's about being blind right when we need to see the most.
Okay, let's get right into it. In November of 2025, this number was everywhere. Over 1,600 lives lost. I mean, just think about that. That was the terrible human cost when two storms that seemed totally impossible slammed into South and Southeast Asia at the exact same time.
You know, what made this whole thing so devastating was just how strange these storms were. On the one hand, you had Cyclone Ditwah, which basically just stopped. It was crawling at maybe 2 or 3 kilometers per hour, creating this cloud lock that just dumped an unbelievable amount of rain on Sri Lanka. And then, at the same time, Cyclone Senyar pops up in the Malacca Strait, a place that hadn't seen a cyclone in 135 years. Forecasters were completely and understandably baffled. So these two bizarre events, they set the stage for a perfect but completely unseen storm. It was a total, catastrophic failure of prediction. And the scale of this crisis was just huge. This wasn't one country dealing with a single freak storm. We're talking about 4 nations: Sri Lanka, Indonesia, Thailand, and Malaysia, all getting hit, all overwhelmed at the same time. It showed that this wasn't just an isolated problem, but a massive regional blind spot. So what was fueling all this chaos? Well, it was like a trifecta of climate conditions that basically supercharged these storms. You had a persistent La Niña event, a negative Indian Ocean dipole, and on top of that, incredibly warm ocean water that was just acting like high-octane fuel. All of these huge macro conditions made getting real-time, on-the-ground data more critical than ever before. So the forecasts failed. The historical models we rely on, they were totally useless. It really begs the question, right? What was the real culprit behind all this? And the answer, according to the report we're breaking down, isn't just the weather itself. It's the massive systemic data gaps that left the people who needed to see completely blind. And this brings us to the absolute core of this whole analysis, a concept called data discrimination. It's a systemic failure where we mistake the absence of really good, continuous data in a region, which is often the Global South, for the absence of risk. Let me put it another way. It's this incredibly dangerous assumption that no data means no danger. Now, you're probably thinking, but wait, what about satellites? And that's a great question. The problem is we rely on them way too much. Satellites have 2 huge weaknesses here. 1, they can't see through the thick, heavy clouds of a major storm, and 2, they can't measure the deep ocean heat that really acts as the engine for these cyclones. And as if that wasn't bad enough, the problem gets even worse because of something the report calls the documentation trap. We have gotten really, really good at funding studies and writing reports about the problem. But the money isn't going to what we actually need, the physical hardware, the buoys, the sensors, in the water and on the ground. Now, it's easy to look at the 2025 disaster and think, okay, that's a freak event, a terrible one-off. But the report makes it crystal clear that this was just the latest tragedy in a very predictable pattern of failure. Just look at this timeline. It makes the pattern so obvious. 2017, you have Cyclone Aki. 2018, the Kerala floods. And then, 2025, Ditwah and Senyar. Each one was a catastrophe, and every single one is linked by the same root cause. And this table really breaks down the specifics of that pattern. With Cyclone Oki in 2017, the big failure was not being able to predict how fast it would intensify, and that's because we were missing continuous deep ocean data. Then with the Kerala floods, the lack of local sensor networks meant there were no effective localized alerts. And then in 2025, we couldn't model the storm's bizarre behavior because there just wasn't enough sensor coverage in those absolutely critical zones. Are you seeing the pattern here? Specific data gaps lead to specific, deadly failures. Okay, so the problem is clear. It's systemic, and it's incredibly dangerous. So let's shift gears and talk about solutions. How do we fix these blind spots? Well, the report lays out a really clear 4-step plan. Number 1, build a global system. We have to start treating ocean and weather observation as essential global infrastructure, just like we treat GPS.
Number 2, fund the hardware. We need to reform climate finance so that it prioritizes buying, deploying, and this is key, maintaining physical sensors. 3, use local knowledge. It's so important to integrate the expertise of local and indigenous communities directly into official warning systems. And finally, number 4, mandate adaptive policy. This means updating laws to require data-driven planning, like, for instance, not allowing new construction in known floodplains.
This one quote from the report just says it all, doesn't it? Our climate has moved beyond the capacity of our obsolete data networks. The point is, our climate has changed, but our tools haven't kept up. We're trying to fight a 21st century problem with 20th century tools. And that leaves us with this final, pretty chilling thought. The 2025 disaster exposed a huge blind spot in the Indian Ocean. And it really makes you wonder, if we're blind there, where else are we not looking?